Hi and welcome to this Now Maths video. If you're doing higher GCSE maths, you will have come across lots of graphs and it can be difficult to remember which is which. In this video we'll look at three types of statistical graph that you need to know. We'll look at what they are and how to plot them. The first graph we'll look at is a frequency polygon. A frequency polygon is a graph that shows the frequencies of a set of data. And it looks something like this. You'll notice it has straight lines joining the points, which is essential since a polygon is a shape with straight edges. Let's take a look at how we plot a frequency polygon now. In this example, we're asked to plot a frequency polygon for the heights of the students in the table. The inequalities in the left-hand side of the table represent the range of heights, and the frequency tells us how many students are in each range. So, for example, the top line of the table tells us that there are 5 students who have a height between 150 and 160 centimetres. The second line of the table tells us there are 7 students who have a height between 160 and 170 centimetres, and so on and so on. For us to plot the frequencies onto the graph, we need to find the midpoint of each height range, since there are an infinite number of heights in each range. So the midpoint, or middle, of 150 and 160 is 155. The midpoint of 160 and 170 is 165. 170 and 180 is 175. And finally, the midpoint of 180 and 190 is 185. Now we need a graph to plot these values onto. So we'll have the height on the x-axis and the frequency on the y-axis. Note the zigzag in the bottom left corner is an axis break that allows us to start the scale of the x-axis at 150, so we don't have a graph with lots of blank space. Now let's plot some values onto our graph. First we'll plot the height of 155 centimetres against a frequency of 5. Then the height of 165 centimetres against the frequency of 7. Notice for each of these we move along to the x value first and then up to the y value second. When we've plotted the 4 points, we join the points with straight lines, and this is our completed frequency polygon. Next we'll take a look at what a histogram is. A histogram looks very different to a frequency polygon because it is made up of bars and each bar has an area that is proportional to the frequency it represents. A histogram looks like this, and because the bars have areas proportional to the frequency, the larger the area of the bar, the larger the frequency it represents. Note this is different to a bar chart because it's used for continuous data. The bars are touching each other, and you might even notice that the bars can be different widths too. Now let's have a look at how to draw a histogram. So, in this example, we're asked to draw a histogram to represent the test scores in the table. To draw a histogram, we need to work out the frequency density of each interval. Frequency density is calculated by dividing frequency by class width. We have all the frequencies in our table, but we will need to work out the class width. Class width is the difference between the upper and lower limits of each interval. So looking at the first row in the table, it goes from 0 to 5, and 5 subtract 0 is 5, so the class width is 5. Now for the second row, the interval goes from 5 to 9, and 9 subtract 5 is 4, so the class width is 4. For the third row, the interval goes from 9 to 15, and 15 subtract 9 is 6, so the class width is 6. And finally, the final interval goes from 15 to 20, and 20 subtract 15 is 5, so we have a class width of 5. Now to work out frequency density, we need to divide each frequency by the corresponding class width. So starting with the first row, 8 divided by 5 is 1.6, which is our frequency density. Then for the second row, 10 divided by 4 is 2.5. The third row, 12 divided by 6 is 2. And finally, 6 divided by 5 gives us 1.2. Now we have all the frequency densities, we need a graph to plot onto. So we'll have the test score on the x-axis and the frequency density on the y-axis. For the first row in our table, we'll need to draw a bar that goes between 0 and 5 on the test score axis, and the height of the bar will be 1.6, which is the frequency density. So our bar will look something like this. For the second row in the table, we'll need a bar that goes between 5 and 9 on the test score axis and has a height of 2.5, which is the frequency density. For the third row, we'll have a bar that goes between 9 and 15 with a height of 2. And finally, we'll have a bar that goes between 15 and 20 and has a height of 1.2. This is our complete histogram, and the great thing about this histogram is that if we were to work out the area of each bar by multiplying the width by the height, it would tell us the frequency that each bar represents. The final graph we'll take a look at is a cumulative frequency graph. A cumulative frequency graph is a curve that shows the running total of frequency. A cumulative frequency graph looks like this and looks different to the previous graphs because it's joined by curved lines, though this isn't the only difference, so let's take a look at how to draw one. In this question, we're asked to plot a cumulative frequency graph for the weights of the potatoes in the table. Cumulative frequency means running total of the frequencies, so it shows how the frequency accumulates as we move down the intervals in the table. We'll add an extra column onto our table for cumulative frequency. For the first row in our table, the cumulative frequency is just 4 because there are 4 potatoes that weigh between 140 and 180 grams. Now for the second row of our table, we need the running total of all potatoes that weigh up to 220 grams. So we have the 4 from the first interval plus 7 from the second interval, which is 11 in total. So the cumulative frequency is 11. Now for the third row, we need the running total of all potatoes that weigh up to 260 grams. Our running total from the previous intervals is 11, and we now have an additional 6 from this interval, which gives us a cumulative frequency of 17. Finally, for our last row, we need the running total of all potatoes that have a weight of up to 300 grams. So we have our running total from the previous intervals, which is 17, plus an additional 3 from this interval, so the cumulative frequency is 20. This means that the table shows the weights of 20 potatoes in total. Now we need axes to plot this information, and we'll have weight in grams on the x-axis and the cumulative frequency on the y-axis. You will notice we have an axis break on the x-axis again to allow us to start the scale at 140 grams. The first point we will plot is 140 grams on the x-axis against a cumulative frequency of 0, since no potatoes have a weight less than 140 grams. To plot the rest of the graph, we need to plot the cumulative frequencies against the end point of each interval, since we can only say we've reached the running total when we are at the end of each interval. So we'll plot the cumulative frequency of 4 against 180 grams. Then we'll plot the cumulative frequency of 11 against 220 grams. Then we'll plot the cumulative frequency of 17 against 260 grams. And finally, the cumulative frequency of 20 against 300 grams. When we've plotted all of the values, we'll join with a nice smooth curve. This is our complete cumulative frequency graph. Thank you so much for watching this Now Maths video. Please like if you found this helpful and subscribe for more help with your maths. See you next time.